Okay, lesson 11.4. We're going to talk about secant lines. This is 11.4. All right. Secant lines are lines that intersect a circle at 2 points. So in this case, this line AB goes through the circle at 2 points, making it a secant. Okay, remember a tangent line intersects a circle at 1 point. Okay, so there's a difference. Now we're going to use the secant lines. When you draw two secant lines in a circle, it creates a couple of different angles. Okay. So in this case, we have two secant lines intersecting in a circle. Okay, so the angle inside the circle is going to be half of its intercepted arcs. Okay, so in this case, it'll be half of the sum of those two arcs. All right, so let's say this was, I don't know, 50, and this was 60. Okay, so this angle 1 right here would be half of those two arcs added together. So it's half 50 plus 60. So that's going to be half 110, and half of 110 would be 55 degrees. Okay, now that angle is not a central angle because its vertex is not in the center of the circle, so don't get that confused. Don't think that angle 1 is automatically 50. All right, this is not a central angle. This is an angle created by two secant lines. Okay. Now, if you have these two lines intersecting outside the circle, all right, we switch it up. We're going to subtract its intercepted arcs and then cut it in half. All right, and sometimes you'll have a secant and a secant. Sometimes you'll have a tangent and a secant. And sometimes you'll have two tangents. Okay, that's how this works. All right, so for example, if I want to find this angle here, it's going to be the difference between these two arcs and then divided by 2. Okay, so let's say this was 150 and this arc right here was 50. All right, so this would be 1/2 150 minus 50. So it'd be 1/2 of 100, which is 50 degrees. That's how that works. So let's do a couple of those together. Okay, these two lines intersect inside the circle, so the measure of that angle, in this case it's x, is equal to 1/2 the sum of its two intercepted arcs, which is 90 and 46. So it'd be 1/2. 90 plus 46 is 136. So it's half of 136, which is 68 degrees. Now this one here, you have the two lines intersecting outside the circle, so, all right, we are going to subtract our two intercepted arcs. So the measure of the angle is equal to half of the bigger arc minus the smaller arc. All right, we have to always subtract smaller from the bigger. So in this case, I know the angle. I'm going to put that over here. That's 20. And we have half of the bigger arc is 95. And our smaller arc in this case is z. So we're trying to find this arc. So we're going to use the same formula, except now we're going to try and get z by itself. So to do that, first I'm going to cancel this fraction by multiplying it by the reciprocal of half, which is 2. So that gives you 40 equals 95 minus z. Now I'm going to subtract 95 from both sides. So that gives you negative z equals 40 minus 95, which is negative 55. And then I'm going to divide by -1. And my missing arc right here in this case was positive 55. Okay, let's try another one. Okay, for this one we're going to find the value of this angle. All right, now these two lines are intersecting outside the circle, so that would be the measure of the angle is equal to 1/2 the bigger arc minus the smaller arc. Okay, so let's see what we know. The angle is x. Okay, 1/2. The bigger arc is 268, so it's 268 minus 92. Perfect, so we have 1/2 268 minus 92. That's 176. Now I just take half of that, and I should have my angle. Divide that by 2, and we get 88 degrees. Okay, let's try the next one. All right, this one involves photography. So let's say you're standing here, all right, and you're focusing your camera on this fountain. Your camera is at at the vertex of the angle formed by the tangent. So these lines right here are tangents because they hit the circle at one spot. So uh, you estimate that the angle right here is 40 degrees. So we need to find how many degrees of that fountain are going to be contained in that picture. Okay, so we're finding the smaller arc. Now these two lines are intersecting outside the circle, so the measure of the angle is equal to half the big arc minus the small arc. All right, the angle is 40. Now the big arc, which is all the way out here, all right, I don't know either of these arcs. I know the smaller one is x. I know that. This is the small, and this is the big. All right, so since I don't know any of those numbers, I'm going to have to write an expression for the big arc. All right, now all the way around in a circle is 360. So if I took 360 and subtracted the small arc, I know my big arc would be 360 minus x. So it'd be minus that small arc. So it's 360 minus x. All right, so let's do the math here. I'm going to simplify inside my parentheses. That's 360. Negative x minus x would be negative 2x. Now I'm going to times both sides by 2, cancel my fraction, so that's 80 equals 360 minus 2x. I'm going to subtract 360 from both sides. So that's negative 2x equals 80 minus 360 would be negative 280. And then I'm going to divide by negative 2, and x equals positive 140. So that is the measure of this angle right here, positive 140. Now just so we're making sure, this angle, or I'm sorry, this arc AEB is 360 minus 140. So that's 220 degrees for that one, just to make sure we understand what we're doing. Put those together, you get 360, and so it works. All right, here's another example. An advertising agency wants a frontal photo of a flying saucer. All right, right at the amusement park. Photographer stands at the vertex of the angle formed by the two tangents of the flying saucer. So here's your tangent line, TX and TY. They hit the circle at one point. What is the measure of the arc that will be in the photograph? So this red arc is X. That means the blue arc would be 360 minus X. And we're going to set it up the same way. So the measure of the angle is equal to half. And since the lines are intersecting outside the circle, we're going to find the difference. The big arc minus the small arc. So the angle, which is 72, is 1/2 the big arc, 360 minus x, minus the small arc, which is x. And we're going to do this the same way we did the previous example. So we have 360, and those two together give you negative 2x. We're going to multiply both sides by 2 to cancel our fraction. So that's 72 times 2, which is 144. Now we have 360 minus 2x over here. We're going to subtract 360 from both sides. Okay, so 144 minus 360 would be negative 216. And we have negative 2x left over here. And then we're going to finally divide both sides by negative 2. And x equals 108. So 108 would be the measure of that arc. Okay, so that is dealing with angles created by lines intersecting inside or outside of a circle, whether they're tangents or secants. Now we're going to figure out segment lengths. Now there are three main formulas depending on what type of diagram you have. So case 1, we have two chords. Okay, so if this is the diagram we're dealing with, we are going to use this formula. So we're taking each piece of each arc, or each chord, sorry, and we're going to times those together and set them equal to each other. And that's going to allow us to solve for one of the missing pieces that are going to be in our problem, okay? In this next problem here, we have two secant lines. So when we have two secants, we have this formula, which is a lot lengthier. Basically, what happens is the formula is take one secant, add the two parts together, and then times by the outer piece and set it equal to the same pattern on the other one. Add the two parts together, y plus z, and times it by the outside part of that secant. And you'll see how that works in a few. Case 3, we have a tangent and a secant. So it's important to know these terms. Now this one, the secant part is the same, so we're going to add the two parts, y plus z, and then times it by the outer part. And then the tangent portion on the other side of the equation is just that tangent, that length squared. Okay, so let's try a couple of examples. So here's a case, this would be a secant and a secant. So this is case 2, right? Secants, two secants. All right, so our formula, which is this formula right up here, let me write this out. So this is w plus x times w equals y plus z times y. Now, w plus x, I'm going to label this first secant, w is 6, x is 8. On the second one, y is 7 according to the diagram, and this is actually z. I'm going to change that to z, okay? Let's plug it in. So it would be 6 plus 8 times 6, and over here we have 7 plus z times 7. I'm going to simplify this side. So 6 plus 8 times 6 would be 84. Now over here we're going to have to distribute. So that would be 49 plus 7z. And now I can subtract 49 from both sides. Let me give myself some more room here. So 84 minus 49 would be 35. Over here we have 7z. I'm going to divide by 7, and z equals 5. Perfect. So z equals 5. All right, over here, example B, this is a tangent. So we have a tangent and a secant. All right, so that's going to be this formula. So let me write out my formula. Y plus z times y equals t squared. Let me label these. All right, t is the tangent portion, so that's t. This would be my y. This would be my z. Let's plug in our information. Y is 8, so it'll be 8 plus 16 times 8 on that side, and over here we have t squared, which is z squared. I'm going to simplify that side right there. So 8 plus 16 times 8, 192 equals z squared. Okay, now I'm going to undo my square by square rooting. That cancels the square. And I'm going to take the square root of 192. And this says if the answer is not a whole number, round to the nearest tenth. So we should end up with 13.9. And that would be the length of that. Okay, let's try another example here. All right, so this this one is two chords. All right. So going back to our diagram, two chords is this equation right here. A times B equals C times D. Let me write out that. So it would be A times B. Actually, I don't need parentheses. A times B equals C times D. Now A and B are from the same chord, so let's call this chord, let's call this A and this B, and let's call this chord the C, and the D. So it's 5 times x equals 3 times 7. So do the math here. That'd be 5x equals 21. Divide by 5. And x equals 21 divided by 5, 4.2. That one's pretty easy. All right, let's try this one. Okay, this one is a tangent, right? Tangent line right here, and a secant. All right, so that formula was y plus z times y equals tangent part squared. Let's label it, okay? This would be my y. I'm going to change that to z, and this would be my t. They always do that. They throw an extra y in there to confuse you. So this would be 8 plus z times 8 equals 10 squared. Okay? I'm going to distribute my 8, so that's 64 plus 8z, and this over here would be 100. I'm going to subtract 64 from both sides, so that's 8z equals 100 minus 64, which is 36. Then I can divide both sides by 8, and I'll have that missing part, which is this part, 36 divided by 8, which is 4.5. And this one is a combination of a bunch of them, okay? So this is actually we'll use this as a summary, okay? So let's start with finding angle A right here. All right, so angle A, this angle is created by two lines that intersect outside the circle. So the measure of angle A is equal to 1/2 the difference between the big arc and the small arc that it intercepts. Okay, so angle A, we'll leave it as A, and then we have 1/2. The big arc would be 175. And the small arc right here is 60. So this one looks like it's pretty easy. So we'll go 1/2, 175 minus 60, which is 115. And now take half of 115, and we'll have our angle A, which is 57.5. So that part reviewed uh, the angle created by intersecting lines. In this case, it was outside the circle. Okay, so that's that part. Erase that. All right, let's go to the next one here. Next, we'll find x. So what I'm going to use is I'm going to use this as a secant, and so is this. So for x, we're going to use the formula that deals with two secants, which is w plus x times w and y plus z times y. So I'm going to label this. W and y are always the outside portion, so this is w, this is x, 8 would be y, and x would be z. Plug everything in, it's going to be 9 plus 12 times 9 on that side, and over here we have 8 plus z times 8. I'm going to calculate that side first. 9 plus 12, and then multiply it by 9. We get 189. Over here I'm going to distribute, so that's 64 plus 8z. Now I can subtract 64 from both sides. So 189 minus 64 would be 125. And over here we have 8z. Now I can divide by 8, and I should have my missing measure. So this part right here would be nearest tenth 15.6. Okay, finally, let's find this side here. So let's get rid of some of this mess. Okay. And let's use a different color. Let's use green. So this is a tangent, and I'm going to use this secant right here. So we're going to use the secant tangent formula, which is, y plus z times y equals tangent part squared. So this is y, this is z, and this is my tangent. So it's 9 plus 12 times 9. And over here we have y squared. This we already figured out from the previous problem was 189. So only thing we have to do here is square root that. Square root of 189 should give us our answer. And rounded to the nearest tenth is 13.7. So that kind of summarizes the whole lesson. All right, thank you.